Hello, everybody. Welcome back. Today we're going to be looking at Unit 4.3, which is called Representations of Reactions, which is just looking at a more visual way to see a chemical reaction. So let's get started. So what I'm going to show you today is essentially just a bunch of examples of what questions looking at representations of reactions would look like. And instead of writing out reactions with their element symbols and subscripts and coefficients, you will sometimes see reactions written, in particle form, okay, like this one. So let's look at this question. It says, a mixture of carbon monoxide and oxygen gas is placed in a container as shown above. Okay, and if we look at you'll always be given a key. We can see that the darker shaded circles are the carbons, the white circles are the oxygen, and if they are touching each other, that is indicating that they are bonded together. It says a reaction occurs forming CO2 gas. What would the contents of the box look like after the reaction has proceeded as completely as possible? Well, what I would recommend doing, since they've told us what the reactants are and what the product is going to be, let's write out an equation and then let's balance it. So carbon monoxide plus oxygen gas yields CO2 gas. It's not balanced at the moment, so let's balance it. And remember that coefficients are just telling you the ratios in which those reactants and products are going to interact with each other. So for every oxygen molecule, 2 carbon monoxide molecules are going to interact with it to form 2 carbon dioxide molecules. All right. So if you look at this drawing that I have here, I have in the box, I can see that there are 4 molecules of carbon monoxide. And when you're shown number of molecules, okay, or atoms or particles, you can always sort of translate that into number of moles. All right, I can also see that I have 3 molecules or moles of oxygen. And the question is, how much CO2 is that going to make? So I want you to pause the video here for just a second and just think through this for a moment and think about what the product is going to look like. All right, so let's see how you did. Okay, this is the drawing on the right there is what your answer should be. And let me just write this back in again. The materials I had to work with and the amounts. I want you to notice that the coefficient for carbon monoxide is a 2 and carbon dioxide has the same coefficient. Okay, so I have enough pieces. I have 4 moles of CO. I have enough material that I can also make that same number, same coefficient, same number of molecules of carbon dioxide. Okay, and if you count them, 1, 2, 3, 4. All right, but I didn't use up all of the oxygen. I had some left over right here. Okay, and this gets into a little bit of something we're going to talk about in 2 subunits from now about limiting reactant and excess reactant, but you don't really have to think about that so much here. You can literally just rearrange the atoms. Okay, let's look at another example. All right, this one says, which of the following particulate diagrams best shows the formation of water vapor from hydrogen gas and oxygen gas? Again, I would recommend, before you try to answer this question, writing out a reaction, a balanced reaction. Okay, let's think about how hydrogen exists by itself. Hydrogen, if you're remembering, guys, exists. Oops, let me change color. It's one of our diatomic elements, H2. Oxygen, also a diatomic element. And it says that when we put these two together, we are going to form water vapor here. Okay. Before I even think about balancing this, I can see right away two of my answer choices can be eliminated. Look at how hydrogen and oxygen are diatomic. I can get rid of answer choices A and B because it's showing the atoms individually. They're not paired up. Like look over at C and D. C and D, they're showing hydrogen and oxygen as diatomic as they should be. So A and B are out. Now let's come back and balance. All right. To balance this, I'm going to put a 2 right there and a 2 right there. Okay. Now let's look at our answer choices between C and D. And let's count number of particles. Hydrogen is the smaller diatomic atom than oxygen. All right. So letter C is showing me 1, 2, 3, 4, 5, 6 hydrogens and 3 oxygens. Okay. And then look over on the product side. It's showing me 6 water molecules. Okay, let's look at letter D. Letter D is showing me 6 hydrogens and 6 oxygens. And we have 6 water molecules. Okay, and neither drawing is showing anything left over. All right, so I'm hoping you're able to pick this up. C is going to be our answer here because look at the ratios. Without having any excess reactant left over, if these were to react perfectly, I should have twice as much hydrogen as I do oxygen, and letter C fulfills that need. Okay, if letter D were to react, we would get 6 water molecules, we would, but there would also be some leftover oxygen floating around in the container, and I can see that there isn't. So letter D is not what occurred. Okay. I want to give you a chance to try this guy on your own. So it says we've got hydrogen peroxide and it decomposes according to the equation above. So this time they've actually given us the balanced equation. It says the reaction is thermodynamically favorable at room temperature. That's a term you haven't heard before. We will talk about it in a later unit. It just means it occurs by itself spontaneously. A particulate representation of the reactants is shown below in the box on the left. In the box below on the right, draw the particulate representation of all the molecules that would be produced from these 4 reactant molecules. So not only do you need to draw the molecules correctly, but also the correct numbers. Okay, so pause the video, see if you can try this one. All right, let's see how you did. If you did it right, your drawing should look like that. Okay, the molecules are colored a little darker than they were on the left, but that's okay. All right, notice up in the balanced equation, the coefficient for hydrogen peroxide and water are the same. So if I have 4 molecules of hydrogen peroxide, I should have 4 molecules of water in my products, which I do. There's 4 water molecules drawn here. And again, look at your coefficients. Half as much, so not 4 oxygen molecules, but just 2. Okay. So not only do you need to draw the molecules correctly, but you also need to draw the correct number as well. So that's just a more visual way to look at a chemical reaction and look at the ratios of how things are reacting and being produced. So I hope you learned a little something, and I look forward to seeing you next time.